Okay, here are your notes for probability. So this is just basic probability. There's two different types of probability. Want you guys really to understand, to be able to know the difference between them. That is theoretical probability and experimental probability. It's two different ways of finding the probability of something. Also, you should know some different simulation methods. All right. So the probability of an impossible event is 0%. All right. So if it's impossible, it's not going to happen. So there is no chance of it happening. So 0%. The probability of a certain event is 100%. That means it's going to happen. So it's a 100% chance that it will. All right. Then all other probabilities of any other event would be between 0% and 100%. All right. So if you get a probability that's over 100%, that tells you did something wrong. All right. So just be careful with that. All right. So the first probability we're looking at is experimental probability. So with experimental probability, it's the number of times that the event that you're looking for happens over the total number of times that you ran your trial. Okay? So, finding experimental probability, right, in a teacher's parking lot, there are 80 cars. Of those cars, 20 of them are trucks. What's the experimental probability that if you ask one of these 80 teachers with a vehicle parked in the lot that they said they are not driving a truck? All right? So we want the probability of not driving a truck. All right? So 20 of them had trucks. There were 80 total, so 80 minus 20 gives us 60 of them didn't have trucks. So it would be 60 out of the total, which is 80, which reduces to 3/4 or 75%. All right, so your answer can be in either one of these forms, reduced fraction or a percent. All right, so either one of those forms is fine. All right, so there's a U try. It should be fairly easy. Go ahead and do it, and then we'll come back and if you have questions on it, you can ask me questions. All right. So the next thing we're doing, this one was example 2 was a simulation method. We're not going to do this because you really need the graphing calculator to do it with that. Just be aware of the different ways you can simulate something happening. You could put numbers in a hat. You could make a wheel and spin to get the different things. For instance, this one says it has 4 choices. So we could put numbers in a hat. We could put the numbers 1 through 4. Into a hat, and then we could shake it up and just draw them out one at a time. So that's one simulation method, way of doing it. We could also make a spinner. All right, make all the sides equal. All right, put a spinner on there, and we could spin that and put the numbers 1, 2, 3, and 4 on there, and then we could see what numbers we get out. We could also do like a big dartboard, and then separate it into 1, 2, 3, 4, but they should all be the same size. And then spin somebody around and have them throw a dartboard at it and do it that way. So there's different ways you can simulate it. So you just understand the different simulation methods. All right. So we covered experimental probability. Now we're going to cover theoretical probability. One of the things you have to know is that the sample space is the number of things that are in there, all the possible outcomes. All right, and when every one of the things in there has the same chance of happening, it's said to be equally likely outcomes, and that's what you want. Is you want it to be equally likely outcomes. All right. Theoretical probability. So now this is in theory. So this is where we're not doing an experiment. We're just saying, okay, this is what should happen in theory, what should actually happen, and we're not going to do an experiment. So, the probability of something happening is the number of times that it can happen over the total number of times that anything can happen. Okay, so that's basically what theoretical probability is. It's just in theory. The probability of an event occurring is probability of the event is the number of times it can occur over the total number of things that can happen. All right? So the number of times the event occurred over the total number of times any event can happen. All right, so here we go. What's the theoretical probability of rolling a 3 on a single die? So we're not going to roll the die. All right, just in theory, what should happen? Well, the probability of rolling a 3 is equal to, well, there's 1 3, so that's the number of times that it can occur is 1, and there are 6 possible choices on the dice. So the probability of rolling a 3 is 1 out of 6. All right? And that's theoretical probability. We didn't roll dice. We didn't do any experiment with it. We just said, well, in theory, what should happen. All right. So what's the theoretical probability of getting the sum of 6 on a single roll of 2 dice? All right. So the probability of a sum of 6. That means the 2 dice have to add up to 6. All right, so this one, what you got to do is you got to do a die 1 and the outcomes. So it could come out 1, 2, 3, 4, 5, or 6. And then you have die 2. All right. Now, if you roll a die with, or 1 with die 1, die 2 could come up a 1, 2, 3, 4, 5, or 6. These are all the possible outcomes. All right. And in fact, any number you roll, the die could come up 1, 2, 3. So we'll just do that for all of these. 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so these are all the possible outcomes that you can get from rolling 2 die. All right, so if you're ever given that problem, this is where you have to set it up. All right, so what there is there's 6 rows and 6 columns. Or 6 columns, 6 rows, all right? So that means there's 36 different outcomes. So that 36 is the possible outcomes. So there's 36 different outcomes. All right, so now we want to find out the sum of a 6. Well, if we roll a 1, we could get a 5, and 1 plus 5 gives us a 6, so that's 1. If we roll a 2, we could roll a 4, and 2 plus 4 is 6, so that's another one. We roll a 3 with die 1. We can roll a 3 with die 2. That gives us another one. A 4 with die 1 gives us a 2. A 5 with a 1. And then a 6, that can't happen. If we get a 6 with die 1, there's no way we can get a 6. So 1, 2, 3, 4, 5. So there's 5 different ways that could come out. All right, so 5 out of 36 is the probability for that. All right, you got 2 U-tries for you to do. All right. All right. So this next one is finding probability using combinatorics. Actually, I'm just going to stop right there. All right, just stop with the experimental and theoretical, and then you make sure you do the U-tries, and then I'll give you a couple homework problems.